Hey there, welcome. We're about to jump into a huge part of probability, and it's something you've probably been doing your whole life without even thinking about it. This is calculating independent events. Have you ever flipped a coin twice or rolled a multiple dice? The outcome of the second coin flip has absolutely zero impact based on whether the first was a heads or a tails. That's the main idea we're breaking down here. Let's just recap what we discussed last time about independent events. Really clear definition. When one thing happens, the universe just doesn't care, it has total amnesia, and it has no say on what's going to happen in the second event. That's what we call independent events. For example, rolling a dice doesn't affect the second outcome. So if you roll it the second time, it doesn't matter what you got the first time. However, if you pick an ace out of a deck and you don't put it back, that's one less card in the deck, and that changes the whole game after that. If you reset it by putting the ace back, we call that with replacement. So this is something called the sample space. Sample space might be a new term, but all it means is all the possible outcomes. So if you're talking about sample space for rolling a die, that's just the numbers 1, 2, 3, 4, 5, 6. Those possibilities don't change. So that's like with replacement. Just make sure that the sample space doesn't change. Once you take something from a deck, you look at it, but the final step is to make sure that you put it back. That's when you've hit the reset button. The next drawer will have the same 52 cards. If every single drawer has the same 52 cards, the same odds, every time the deck is reset, that's when we know we've got independent events. Right, now if we want to calculate the odds of 2 or 3 or more things happening, well, this is what we do. We discussed this briefly in lesson 1. All you have to do is multiply the probabilities of 2 independent events, and you get the probability of that outcome. Let's try this out in a real-world example. We'll stick with a deck of cards. What's the chance that you draw an ace, 4 out of 52, then you put it back, shuffle the deck, and then you draw a red card? Well, half the cards are red, so that's 26 out of 52, right? Half the deck. Since we put the first card back, that is, therefore they're independent. So all we have to do is multiply those two together and we get an answer just under 4%. This isn't just for games though. Let's think about a factory, for example. Let's say the chance of one machine putting out a defective part is 2%, and another machine having a defective part is also 2%. But the first machine and the second machine are different machines. So the chance of one doesn't affect the other. Multiply them together, and you get just about 0.04%. Right, let's think about something a bit more high stakes. Let's think about your PIN code for your phone or your bank card. The secret here is that the digits can repeat. That's just another way of saying with replacement. If you pick a 7 for your first number, that does not mean that you can't use that 7 again. So let's build a 4-digit code together. For the very first slot, we have 10 options, 0 through 9. That's 10 choices. For the second slot, we have the same 10 choices. And the third, and the fourth. So if we multiply those 10s together, that means we've got a total of 10,000 combinations. That means if someone tries to guess your PIN, their chance is just 1 in 10,000. It's a simple multiplication of independent events that makes digital stuff secure. Okay, we've gone through a lot, so let's boil this down to one single important question you can ask yourself every time you run into a probability problem. Just stop and ask yourself this question: does the first event change the pool of possibilities for the second one? Does taking out a card from the deck change what's left? Does using the number 5 once mean you can't use it again? If the answer to that question is no, then you've got independent events. You can go ahead and use that multiplication rule. If the answer is yes, you're in a whole different world of probability, and that is dependent events, which is super interesting, but for another time. Think about this. How many events in your own life that feel random are actually connected? And how many actually are completely independent?